Arrays interview questions and answers. Beginner means advanced. Introduction. This is a structured set of commonly asked array interview questions with clear answers. It covers array fundamentals, operations and complexity, searching and sorting, two pointers and sliding window, hashing and optimization techniques, advanced array patterns. This topic is core for coding interviews in almost every language: Java, Python, JS, C++. 1 to 20. Array Basics 1. What is an array? An array is a linear data structure that stores elements in contiguous memory locations. 2. Why use arrays? Keyboard, fast access by index, simple structure, efficient iteration. 3. What is indexing? Accessing elements using position. 4. Array indexing starts from 0, zero-based indexing. 5. What is size of array? Number of elements it can hold. 6. Static versus dynamic array. Static means fixed size. Dynamic means resizable. 7. Examples of dynamic arrays: ArrayList, Java; vector, C++; list, Python. 8. Time complexity of accessing element. O(1). 9. Time complexity of searching element. O(n). 10. Time complexity of inserting at end. O(1). Amortized for dynamic arrays. 11. Time complexity of inserting at beginning. O of n. 12. Time complexity of deletion. O(n). 13. What is contiguous memory? Elements stored next to each other in memory. 14. What is array traversal? Visiting all elements. 15. What is multidimensional array? Array of arrays. 16. Example of 2D array: 1, 2, 3, 4, 5, 6. 17. What is jagged array? Array with different row sizes. 18. What is array overflow? Adding elements beyond capacity. 19. What is array underflow? Accessing empty structure. 20. What is advantage of arrays? Fast access, simple implementation. 21 to 40. Searching and sorting basics. 21. What is linear search? Check each element one by one. 22. Time complexity of linear search. O(n). 23. What is binary search? Divide and conquer search technique. 24. Requirement for binary search. Array must be sorted. 25. Time complexity of binary search. O of log n. 26. Example binary search. Mid equals low plus high divided by 2. 27. What is sorting? Arranging elements in order. 28. Types of sorting. Bubble sort, selection sort, insertion sort, merge sort, quick sort. 29. Bubble sort complexity. O(n) squared. 30. Merge sort complexity. O(n) log n. 31. Quick sort average complexity. O of n log n. 32. What is stable sorting? Preserves order of equal elements. 33. What is in-place sorting? Uses minimal extra memory. 34. Merge sort stable. Yes. 35. Quick sort stable. No. 36. What is partitioning? Dividing array into parts. 37. What is pivot? Element used in quicksort partitioning. 38. What is recursion in sorting? Function calls itself. 39. What is heap sort? Sorting using heap data structure. 40. Heap sort complexity. O(n) log n. 41 to 70. Advanced array techniques. 41. What is two pointers technique? Using two indexes to solve problems efficiently. 42. Use case of two pointers. Sorted arrays. Pair problems. 43. What is sliding window? Technique for subarray problems. 44. Fixed versus variable sliding window. Fixed means constant size, variable means dynamic size. Example sliding window. Maximum sum subarray. 46. What is prefix sum? Cumulative sum array. 47. Why prefix sum? Fast range sum queries. 48. What is suffix sum? Sum from end to start. 49. What is hash map usage in arrays? Fast lookup of elements. 50. Example problem using hash map. 2 sum problem. 51. What is frequency array? Counts occurrences of elements. 52. What is Kadane's algorithm? Maximum subarray sum algorithm. 53. Kadane's time complexity. O(n). 54. What is subarray? Continuous part of array. 55. What is subsequence? Not necessarily continuous. 56. Subarray versus subsequence. Subarray means continuous. Subsequence means not continuous. 57. What is rotation of array? Shifting elements left, right. 58. What is cyclic rotation? Last element becomes first. 59. What is matrix array? 2D array representation. 60. What is spiral traversal? Visiting matrix in spiral order. 61. What is transpose of matrix? Swapping rows and columns. 62. What is diagonal traversal? Visiting diagonal elements. 63. What is search in rotated array? Binary search variation. 64. Time complexity, rotated search. O of log n. 65. What is duplicate detection?
Finding repeated elements.
66. What is sorting-based duplicate check? Sort plus linear scan. 67. What is optimal duplicate detection? Using hash map. 68. What is majority element? Element appearing n times now. 69. Algorithm for majority element. Boyer-Moore voting algorithm. 70. Time complexity. O(n), O1, space. 71 to 100. Optimization and interview patterns. 71. What is time complexity of arrays? Depends on operation O1 to On. 72. What is space complexity? Memory usage of algorithm. 73. What is brute force approach? Checking all possibilities. 74. What is optimized approach? Reducing complexity using patterns. 75. What is greedy approach? Making local optimal choice. 76. What is divide and conquer? Splitting problem into subproblems. 77. What is dynamic programming? Storing overlapping results. 78. Array DP example. Maximum subarray, stock problems. 79. What is stock buy-sell problem? Maximize profit from prices array. 80. What is interval problem? Working with ranges. 81. What is merge intervals? Combining overlapping intervals. 82. What is insertion in sorted array? Maintaining order. 83. What is binary insertion? Inserting using binary search. 84. What is heap usage in arrays? Finding min-max efficiently. 85. What is priority queue? Heap-based structure. 86. What is kth largest element? Solved using heap. 87. What is top k elements problem? Heap or sorting. 88. What is array flattening? Converting multidimensional to 1D. 89. What is sparse array? Array with mostly empty values. 90. What is memory optimization in arrays? Check, avoid duplication. Check, use in-place algorithms. 91. What is stable versus unstable operation? Stable means preserve order. Unstable means does not. 92. What is cyclic sort? Placing numbers in correct index. 93. What is missing number problem? Finding missing element in sequence. 94. What is XOR trick in arrays? Efficient duplicate missing detection. 95. What is bit manipulation in arrays? Using binary operations for optimization. 96. What is performance bottleneck? Slow operations like shifting elements. 97. What is best use of arrays? Click lookup heavy systems. Seek indexing-based data. 98. When not to use arrays. Frequent insert delete in middle. 99. Alternative to arrays? Linked list, hashmap, tree. 100. How to master array problems. Learn patterns, 2-pointer sliding window. Practice coding problems. Understand time complexity. Optimize brute force solutions. Final summary. Array interviews focus on indexing and memory, searching and sorting, sliding window and 2-pointers, hashing techniques, optimization patterns. Key idea. Arrays are simple but powerful, and most interview problems are pattern-based.